programming is a technique which helps us to find the optimum solution of a given problem. An optimum solution is that solution which is the best possible outcome of a given problem. Before we discuss how a linear programming technique is used to solve problems, let's understand what kind of problems can be solved using this technique. Did you know that this technique is widely used in different industries? This list includes different types of linear programming problems. Let's now focus on the structures and the formulation of linear programming problems. We first need to understand the given problem and then identify the basic elements to convert it into linear programming problem. This process is called as a formulation of a linear programming problem. Understand it well. We first need to convert the given problem into a linear programming problem and then solve it. So, there are two aspects here, the formulation part and then the solution part. Let's begin with the formulation of linear programming problems. Go through this example. We have to find the maximum profit the company can earn with the constraints. The constraints here is the production budget. But how do we approach this problem now? First, let's try to represent this problem in a tabular form. Can you give it a try? Sure, it is. Go through it well. Note that we have to convert this problem into a linear programming problem. And how we do that? By writing the given problem in the form of mathematical expressions, like this case, the company wants to sell some number of products A and B. As they don't know the exact quantity, let's assume the number of units of products A to B X and the number of units of the product B to B Y. Can you tell me the total cost of manufacturing these many units of A and B respectively? Yes, it will be 200 times X and 150 times Y, which is multiplying the quantity with the price. Next, let's look at the constraint. It says the production budget is $50,000. That means the cost to be incurred should not exceed $50,000. It can be less or equal to $50,000. Can you write this constraint in the form of mathematical expression? Here's the answer. This expression represents the budget constraints of the problem. The total cost should not be more than $50,000. Now, let's express the total demand of the two products in a similar manner. Give it a try. The combined monthly demand of the two products will not exceed 500 units. Therefore, we use the less than or equal to sign to write this expression. And which constraints does expression represent? Yes, it represents the demand constraint of the given problem. This means if the company produces more than 500 units of the products, A and B in all, it might not be able to sell them. Are there any other constraints in the problem? Not really. So, let's look at the profit elements of two products. Can you tell me the objective of the company in this case? The company would like to sell its product A and B in such a mix that it yields maximum profit in a month. In simple words, the company would try to maximize the profit which it can yield by selling A and B. Now, let's see the note the total profit for the month. Can you write the total profit in the form of mathematical expression? The total profit set can be written as this. It's the product of the quantity and the profit per unit. With this, we will write the objective function of this problem. The objective function is a linear programming problem, is a mathematical expression of ultimate code. So, We have the two constraints here, a budget constraint and a demand constraint. This is how the whole problem looks in terms of mathematical expression. This is the objective function and these are the two constraints. There's just one thing we need to know here. And for that, I want you to answer a question. Can the number of units produced by a company be negative? You're right, it can never be negative. So, we need to add the non-negative constraints. It can be written in mathematically like this. It's very important to write the negative constraints in the formulation of the linear programming problem. Did you notice what we did? The entire problem of so many words is reduced to the simple format using mathematical language. As the problem is formulated in the linear forms, it's called as a linear programming.